Okay, we start up again. I wanted to show you something, little tip towards this exercise 8 coming up. Well, let me show you first this one. Just search for open foam, convergent divergent nozzle, and then you find this very nice simulation made from these Russian guys. So they have everything set up here. You have some comparison actually from NASA. So you have some data here. So that could be nice. And yeah, they have played around with different measures. So you see the geometry inlet here, nozzle opening, and then sort of a reservoir. So no, I like that one a lot. So this is sort of the aim that you should achieve when we are coming to the exercise 8. Of course, with a structured mesh, we do it easy. And yes, it's two-dimensional, and then we just use a symmetry plane here. So it should be fairly easy geometry. But to make this one work, that's the trick. And then, of course, when the change in the pressure is too low, then you don't get shock waves. Then you have a subsonic setup, and then with the Mach 1, and then even supersonic as well. So here they have done it even in 3D. But what I wanted to show you, not the commercial, thank you. Where are we? Here. Commercial. Here they have some references. Actually, the entire source code of this solver is present. So you can copy the entire source code. And yeah, that should be nice, I thought. So I found it something here. And they have a lot of information here. Warning, 8 and 9 years ago. Just forget it. You can't make that one run. Then you have to have a very, very old version of open foam. But they had some repository here, I think. Let's have a look at that one. Here we go. So this one is more, say, updated. And they had some very nice version of this one. I think it was further down. Let's see. Here we are. So now I was sort of getting my hopes up. This is the same version that I was using. So I thought, beautiful. Then I go in here, find the entire source code, compile it, and then I have the same program as these guys. So that was my aim. And you have the sources, you even have some tutorials here. So it looked very nice. But life is never that easy. So here I have copied it. They have two different versions. One is called Pimple Central Foam, another Row Pimple Central Foam. So here then you will have the setup for compiling your own version. And I thought this one looked very nice. They have the same standard setup with make files and everything. But sadly, when I tried to make this one work, it didn't. Because here, if we have a look inside the source code here, they have a whole bunch of header files that doesn't exist in the standard libraries for open foam. So you have to find those as well. I think there are some links here somewhere, but I haven't actually been able to find them yet. I was struggling with this one a couple of hours yesterday evening, late, and I couldn't make it work, at least not so easy. But it should be possible. I mean, it must be there somewhere. So my idea then could be for you guys if you have trouble finding a solution, a steady, stable solution with the standard compressible solvers in OpenFOAM. What do we have? Row simple foam, row pimple foam, but they are a little bit edgy and jumpy and they explode quite rapidly. Then this program might be more stable, was my hope. Now at least you have learned how to compile the source code and create your own program. So it should be good to go, as long as we can find the rest of the libraries there. I'll have a look at that one later this week before I put out the exercise. If I succeed, then I will give you a hint about it. So yeah, they have two setups here. It was the same with the row pimple central foam, as they call it. So again, a lot of the header files were missing. The tutorial, the setup that they had for one run case, that one was not so impressive. If you look at the mesh, for instance, you could actually see it's a one-dimensional case. So no, he doesn't cover the entire convergent divergent nozzle problem at all. Never mind that. But then you had some other entries here. Let's see now if we search again. OpenFOAM, convergent divergent nozzle. There was another one I wanted to show you. I think it was this one, if I recall correctly, using sonic foam. Yeah, and you need some chocolate. That's nice. 65,000 elements. Shouldn't be too hard. You see the geometry is the same. They have used linear and linear, I think, not curved. I don't think that matters. It shouldn't matter at all. But here also then you should find, say, recipes for solving this exercise. So depending on the driving force, yeah, you may have, of course, Mach 1 here only if it's a strong enough driving force. But then it's a question, do you have higher shocks in this range or even in this range, depending on the driving force in the system. So they don't have as big reservoir as the other one, but I think it still looks nice. And it should be possible to find some information here as well, I think. Not much. It should be possible to find something there. It was another one as well, wasn't it? Where was it? Here we are. More chocolate. It's too expensive, but it's good. You see, you can find several of these setups. The Mach number here should be 1 here in the smallest cross-sectional area. And then I guess they speed up, yeah, the exit pressure here. And then you should have a nice shock structure. Oh yes, beautiful, beautiful. So you will have a challenge for this next exercise. Yeah, it looks like a steady state here now. So I was hoping to show you this simulation then, but as I said, I couldn't make it work, at least not yesterday. I have to fight that one a little more. But then I actually don't have anything more material for you guys today. So as I said, next week then we have to start with combustion. That's sort of the next topic. Any questions from you? Yeah.
You posted the links to the videos?
To the
Videos.
these ones?
Yeah.
No, I haven't done it yet. But I mean, they will be part of the exercise text coming up, so don't worry about it. Other questions? Then we just take an early lunch.